All right, and hello everybody. Welcome to the channel. Today we're going to be talking about geometry problems again. Today's problem is going to be a little bit similar to last video's problem, which was about the area of a circle that had an equilateral triangle inscribed into it. So, how is it similar? Well, we're basically just taking this problem into the third dimension. So let's take a look at the problem. Find the volume of a sphere that contains an equilateral triangular pyramid with side lengths of n. The 4 points of the pyramid are inscribed into the surface of the sphere. So with any type of geometry problem, it helps to visualize the problem whenever possible. So here we have two types of 3D objects. The first one is a sphere, and the second one is an equilateral triangular pyramid, or some people call a tetrahedron. So we're going to start off by drawing the pyramid. An equilateral triangular pyramid means a pyramid that has 4 points. And then we're going to go ahead and draw this. This is going towards the back of the pyramid right here. Because remember, this is in 3 dimensions. There we go. Here's our pyramid. And then our sphere, obviously a circle. And then we're going to take it into 3D. Ooh, how do we make this? Nice. There we go. Nice. So here's our shapes. Here, let me pull this circle out just a little bit, make it more realistic. And then we'll have, there we go. That shows us that it's in both ways, in both dimensions. Towards the back, towards the front. There we go. And then we also know that the side length of one of the sides of the triangular pyramid is n. So I'm going to go ahead and write n in red over here. Now what we're looking for in this problem is the volume of a sphere. This sphere to be in particular. So we've taken some time to kind of visualize the problem. Let's go ahead and think about how are we going to solve this problem. Well, first steps first, we're solving for the volume. This is our main goal. What is the volume of a sphere? Well, if you guys remember, volume of a sphere is equal to 4/3 pi r cubed. So 4/3 pi, these are constants. I don't have to solve for anything, but what we want to focus on is this r, this radius. Now, we don't have any hints about or any direct measurements regarding the sphere, but we do know something about this n. So how can we solve for this r when we know that one of the sides of the triangular pyramid is n? Well, let's take a moment to kind of zoom in to the triangular pyramid. Now, some properties that would be helpful to know about about triangular pyramids for this specific problem would be that the what is it? This distance r is actually the midpoint of the triangular pyramid. Because all of these side lengths are n, n, um, n, and there's an n behind here too, but I don't want to write it because it might confuse you. This distance r is the midpoint, the radius that we're trying to find. Since these are all the same, this distance r, the radius, is actually the midpoint of the triangular pyramid. So we know that r here is the same thing as midpoint of this object. And then one useful thing to know about tetrahedrons is that this distance r, we're using it, r radius, but also here for midpoint, is equal to 2/3 h. So it's 2h over 3. Well, now that we know what r is, we have another unknown variable, which is the height. how can we find the height of this triangular pyramid? Now, don't go too fast and think that the height is going to be the same as n, the same as the side length. That's not true. We're actually going to have to use trig to find out what the side length or the height of this triangular pyramid is. So let's go ahead and take a look. Here is a useful way to kind of find the height of this pyramid. Now, what I drew here is kind of like a triangular plane. Let me just, there we go. Shade it out over here. Ooh, that's a square. Here, I'll draw it in highlighter. This is, think of this as a plane that's cutting into the shape. This right here, since it's a plane, would now be a 90-degree angle, and then we could use trig to help us find the height if we know x. So our next step is to zoom in and find, there we go, find the midpoint of the base. This is the base triangle. Now we're just taking this 3D problem and turning it into 2D sections that are more digestible for our math. So this is the base. Don't think of this as a triangle anymore. We're looking at this right here. This is what we're looking at. What we want to find is that this distance x, so the distance from one vertice to the midpoint of the base. And of course, the side lengths of this triangle are still n. Now, how can we do this? Well, we're going to think about the properties of a triangle real quick. This is just a 2D triangle. So for these properties, let's think about this. We have an equilateral triangle. All the angles are equal to theta. We're just going to say they're equal to theta. I'm going to bisect this specific side. Bisect means that this length is now n over 2. This should be very familiar to the last video. And then we know that since we're splitting up this theta into 2, now we're going to have theta over 2. All right. Now we have some measurements. If you guys remember, theta is equal to 60 degrees, which is equal to pi over 3. Which means that, there we go. Yeah. Just going to write that there. Here is the same diagram that we just drew. Now we're going to take a focus into this little triangle here. Because we have some knowns that we can use to help us figure out this value x. We know that n over here is just going to be a constant. We don't know what constant, but we're just going to keep it as n. And then we know theta. Theta is equal to pi over 3. So theta over 2 is just going to equal to theta times 1 over 2, which is equal to pi over 3 times 1 over 2. So now this is simply pi over 6. And now that we have the measurement of the angle and one side, we can use trig to help us figure this out. So in this case, we have, what are we solving for? We're solving for x over here, and we have adjacent. So adjacent, we have hypotenuse. We're going to use cosine. So the cosine of this angle, theta over 2, or pi over 6, is going to equal, what is it? Sakatoa, you guys remember? So this is adjacent over hypotenuse. I'm going to write this as n over 2 divided by x. So let's go ahead and switch these terms, the x and the cosine pi over 6. We're going to have x is equal to n over 2. I'm just going to put this in parentheses because there's going to be a lot of division. Cosine pi over 6. And this is going to be equivalent to n over 2. Going to keep that the same. All over cosine pi over 6. If we remember back to our trig identities, that is simply this root 3 over 2. And now we have division over division, which is the same thing as division times the reciprocal of this value. Let me move this over real quick. There we go. We continue this problem here. So that's n over 2 times 2, and then over root 3, the 2's cancel out. Now we have n over root 3. We want to make this a standardized value, so we're going to multiply the top and the bottom by root 3 over root 3. That way we don't have square roots at the bottom. And then this is n root 3 over 3. That's the value x. All right. Now, if we take a look back, now that we have x, I'm going to erase this. Now that we have x over here, and we're solving for h, and we know the value n. We don't necessarily know the value of this angle, but since this is a 90-degree angle, we know that we can use the Pythagorean theorem. If you guys remember, that's a squared plus b squared is equal to c squared. Yeah. So let's try using the Pythagorean theorem to help us out. Like I said, this is the base plane right over here. This is the height, and this is one of the sides. So we're gonna have, let's just call this side A, let's call this side B, and let's call this side C. So a squared, which is just height squared, plus b squared, which is x over here, which is this value. I'm just gonna go ahead and plug it right in. N root 3 over 3 is equal to c squared, which is just n. Yeah, n squared. All right, let's go ahead and solve for h. So h squared is going to equal, oh, I forgot the squared, n squared minus n root 3 over 3 squared. Gonna go ahead and take the root. That root cancels with the square. So h is equal to n squared minus n root 3 over 3 squared. Let's go ahead and try to evaluate these inside terms. All right. So h is equal to square root of n squared minus these terms. We're just going to distribute this square out to each and every term, make it easier for us. This is going to be n squared 3 over 3 squared. I'm going to keep the square here for now.
All right, excuse the abrupt pause. I noticed an error in my arithmetic, as that always happens, but I'm back.
Excited. So yeah, let's continue solving for h. Over here, we know that this value over here is going to equal n squared minus, now over here, the 3's, 1, 3 cancels out here, poof, bye bye 3 here, this 2 now turns into 1, so this is simply n squared over 3. I'm going to just add 1, and then, take out this n squared, so 1/3 n squared. That is simply the square root of 2/3 n squared, which is equal to the square root of 2 over 3n squared. And we're going to make this prettier by doing square root of 2 over square root of 3n squared. And that's finally standardized the form. This is going to be, going to multiply these over, there you go. These over here times root 3 over root 3, and then we get a 3 on bottom, and then root 3 times 2, just simple multiplication, that's root 6 n squared. Nice. So now we have the value of the height. So next step, if you guys remember, it was mentioned that the radius is the same thing as the center of the triangular pyramid that we were trying to solve. So what we're going to do now is solve for that. We have height now, so then radius is 2/3 times root 6 over 3n, which is equal to root 6 over 3 squared n. So we finally have a radius, which means that we can plug it into our equation for volume of a sphere. Here's the same value that we just calculated in the previous step, and here's the equation for the volume of the sphere. This is going to be a lot of just balancing out the equation, but or arithmetic. So hold on with me. The volume is equal to 4/3 pi times, I'm going to use the big parenthesis here, 2 times the square root of 6 all over 3 squared n. This is all to the third power. You know what? I'm actually just gonna move this equation here just because I know it's gonna be a lot of numbers. So this is gonna be the same as this 4, since we have a 2 here. This is just, looking ahead. We know that this 3 value is going to be um, distributed to all of these values. I know there's a 2 here, so I'm going to just go ahead and save this by saving myself some time by saying that 4 is equal to 2 to the 2 squared. So let's go ahead and I'm going to put the pi in front. Pi 2 squared over 3 times 2 to the 3. That's that one done. Now 6 to the 3, that's going to be a 6 times root 6. And then this 3 gets distributed here. That's a multiplication of the exponent, so that's 3 to the 6. All right, it's ugly. So let's go ahead and put these two values together. That's equal to, oh, I forgot the n cubed. Let's go ahead and put these two values together. So that's 2 squared times 2 to the third, that's 2 to the fifth. This 6, I'm actually going to break down into a 2 and a 3. You'll see why in a second. Times root 6. Now down here, they just adds up, so this is now 7. So that's 3 to the 7, and then pi n cubed, just pushing that back so it's prettier. Now the reason I split up this 6 into 2 and 3, so this 2 combines with this 2 here, and this 3 cancels out one of the 3's here. So now this is 3 times 6. Let's clean this up a little. This is 2 to the 6 root 6 over 3 to the 6. All of this is times pi n cubed. Now you could leave it in this form, but I'm just going to make it multiply out the math, make it pretty. This is now going to be 64 root 6 over 729 pi n cubed. All right, so this is our final value. Here's our summary. So what is the volume of a sphere that contains an equilateral triangular pyramid inside, of which the sides are all length n? Well, that's just the very simple number of 64 times the square root of 6 all over 729 pi n cubed. Whatever n is, just cube it and multiply it times this. So thank you guys for watching the video. I hope you guys enjoyed it. Always let me know in the comments if you guys see any mistakes or if you guys have any questions that you want to talk about. We're all human. We all have our curiosities. We all make our mistakes. Let me know, and I'll get right back to y'all. Thank you guys for watching. Bye.